Okay, so this one we did. Right. So the thing is, we have to show that. Okay, let me write down. So let G be a graph on with n vertices. Right. So now we have to show that the coefficient of. So we know that the coefficient of a k power n minus one. So that is minus the number of edges, right? So, but the thing is, so we saw a proof using induction, but here they are asking to give a non-inductive proof. So we have to give a different proof other than induction, that the coefficient of k power n minus one is minus the number of edges. Okay.
Oh. Oh, is it not minus one?
No, no, it is minus the number of edges, right? The
The
coefficient
why we have degree is
n,
n,
right?
and the second is negative, not minus a. Uh,
No, it is negative. The
Previously we prove is right.
yes, yes. 1 minute. Let me show you. So I think. Where is that? Mm, chromatic polynomial, right?
Mm.
1 minute. Let me see the proposition numbers. It's 1 minute. No, okay. No. It is as far as recall. So the polynomial is the second coefficient is okay. It is not here. I don't know where it is. But the thing is, the coefficient is minus the number of edges. So uh,
Already prove is right.
yes, yes. We already proved it. But the
Okay,
thing is, we
okay.
used induction. But here they're asking to prove without induction.
Without induction. Okay, okay.
Right, right.
Okay.
So let us see that how to do it. So
Mm.
okay, so
Mm.
let us write. So the thing is, so we saw a proposition that the chromatic polynomial uh, g comma k. So this is nothing but summation r equals to 1 to n
Mm.
pr
Mm.
kr. So where pr is the number of so it is the number of partitions of g into exactly r non-empty independent sets, right?
Yeah, yeah.
Right. So now you can use this one.
Mm.
Right.
Number partition.
Right.
Uh,
Number of partitions into this many exactly are non-empty disjoint sets,
uh,
independent sets.
where it doesn't matter if we divide the Z into partition, but the subpartition should be independent. Yes, is it okay?
Yes, yes. So the thing is how we
Mm.
partition
Mm.
the vertices. So each of the partition will be independent. So they should not have edge in between
Mm.
them,
Mm.
and the number of partitions should be exactly r. So exactly r partitions, and each of the set has to be non-empty, right? And
In dividend set mean they don't have agency
yes, yes, they
uh,
don't have adjacency in between them.
in between the set. Yeah.
Yes, yes, in between the set.
Okay, okay. And kr, what is
Is
kr?
KR that we defined, right? So
The number of
no, no, KR is a polynomial. So so okay, let me define. So
kr
X.
kr is the how to the
No,
what?
no. So this is X into, so XR is X into X minus 1, X minus 2, up to X minus of R plus 1. So this is KR. So KR will be corresponding K into K minus 1 like this. So this is our KR. So this is a polynomial in K.
Yeah. That's the chi b kr is it right?
Yes, yes. So so in
Uh,
fact this
uh,
is comes from your this
uh,
K factorial we have, right? So K factorial divided
mm,
by so this last term if you note.
mm,
So this is K minus of uh, R minus 1, right?
mm,
Right.
mm,
So then, so it is up to right. So this is the decreasing factorial, you can say. So the usual factorial notation is increasing, right? So you can say it is from 1 to 6, right? And
mm,
it is not going up to 1. So it is K factorial, but some terms are missing. Means from the next remaining terms up to 1. So these are missing. That is
mm,
K minus 1, K minus 2 up to K minus of R minus 1. So this is the formula, or this is the notation.
mm.
Okay.
Yeah.
Right. So now since, so this KR is a polynomial in K of degree R. So, so what will be the contribution of K power of n minus 1? So this is a polynomial of degree R, right? So the contribution of so the contribution to the coefficient of K power of n minus 1 in the chromatic polynomial. So that will only come from two terms, right? It
Mm,
can arise from the terms r equals to n and r equals to n minus 1. So only these two terms can contribute to the coefficient of x k power n minus 1, right? Because the
mm,
highest degree of k power r is that is k power r, right? In this kr.
mm,
So if r is smaller than n minus 1, it cannot contribute k power n minus 1, right?
mm, mm,
So only so in this summation there are n terms, but only these two terms, that is r equals to n and r equals to n minus 1. So that will contribute to the coefficient of k power of n minus 1,
mm,
right?
mm.
Fine.
Wait. I said
Yes. Read it once to look clear.
k minus 1, k n minus 1. And, mm, oh,
Right.
yeah. Oh,
So
mm,
so now we have to only look at what is the case for r equals to n and what is the case for r equals to n minus 1, right?
mm,
So what does r equals to n mean? So by definition, that is p of n, right? P of n means the number of partitions into
mm,
exactly n non-empty sets, right?
mm.
So that only partition is every element has singleton elements, right?
Mm, mm,
So the only partition of the vertex set V of G into R equals to n independent sets is the one with each vertex is in a set by itself, right? Right.
mm,
So then, how many such partitions is there? There is only one such partition, right?
mm,
So this implies that Pn, the number of partitions, is one, right?
mm, mm. Yeah, yeah. Mm,
Okay. Now the next case is R equals to n minus one. So when partitioning, so partitioning the vertex set into n minus one independent sets.
mm,
So there must be one set of size 2 and the remaining n minus 2 sets of size 1. So this is the only way, right, to partition.
mm,
So if there are n minus 1 non-empty independent sets, only way we can partition is all the sets should be one element and only one set has two elements, right?
mm,
So how many ways we can do it? So since the two element set has to be independent, so thus such a partition. So each such partition is determined
mm,
by choosing two non-adjacent vertices, right? So if we can choose two non-adjacent vertices, then
mm,
I will keep them into one partition, and remaining all n minus two vertices I can put single into all other
mm,
partitions, right? So how many ways we can choose two non-adjacent vertices?
mm.
Yes, tell me. How many ways we can choose two non-adjacent vertices?
A partition determined by two. Mm. Two non. Mm, mm.
Yes.
One partition into n minus one. N minus one. We have n vertices but into n minus one independent set.
Right.
So so one set must be size two.
Yes. One set has size 2 and all other sets are size 1.
Two vertices and another is one vertices. Is right.
Yes.
Yeah, yeah. So that's okay. So is the third partition is determined by two. Hmm? Third is third partition is determined by two non-adjacent vertices.
Okay.
That's mean the we say about the set which side two is right.
Yes, yes. So the thing is, we are trying to find P of n minus 1, right? How many such partition exist, right? So that will
Yeah,
depend. Yes.
just I don't get the question.
Yes, yes. The question is, so we want to find this one, right? So P of n minus 1. So that we want to find. What is this, right?
B of n minus one.
Right. So what is P of
B
n
of
minus 1?
n minus
So
B
the
of n
definition is,
minus one is the number.
yes,
The
the number
number
of partitions of G into exactly n minus 1 non-empty independent set, right?
the number of partition of G. That's this is not. This is the combination is right.
Yes, yes, that
We
is the
say
definition, right?
yeah, but this we say about the possible number of partition. So that's the some combination of something is right.
Yes, yes. So that
Uh,
is the,
okay.
yes, that is the thing we are wanted to find, right? So this is the,
Mm-mm. So we have two, pick up two, any two, and other is right. So we have two combination of two n minus one.
yes, yes. So the thing is, we have to choose an element or a set of size 2, right? But the thing is that has to be independent also, right?
This is independent. Yeah, yeah.
Yes. So the question is
Uh,
how many ways we can choose such a set.
the not agency, not agency. Two non-agency. What is it? Hmm? Two non-agency.
Right.
What is but how to calculate how many two non-agency? What is this?
Yes, that is what I'm asking. So the thing
Yeah,
is,
yeah, yeah. What? How to?
yes, yes, that is saying I'm saying. So the thing is, so any two vertices I can choose in n choose two ways, right? So the n
N
choose two is
minus
the
one. N minus one or n?
n. So no, no, I'm just choosing two vertices, random any two vertices. So this is the number of ways.
Number of possible s.
So this is the number of ways to choose two vertices, right?
Yeah.
Out of n. But the thing is, I have to choose. So here the specialty is non-adjacent vertices, right?
Yeah, 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 yeah.
So out of this n choose two, how many are them? How many are adjacent? So out of this n
The
choose two,
number the number of s.
right? So the
Okay.
number of edges are the adjacent
So
pairs, right?
so n minus e.
Right, right. So adjacent pairs.
Okay.
So the number of ways to choose non-adjacent will be n choose two minus the number of edges, right?
Uh,
Fine.
yeah.
So that is the once we are done, then it is thus p of n minus one is n choose two
Mm.
minus the number of edges, right? Because once we have choose these
Mm.
two edges, these two vertices, then remaining
Mm.
vertices is only singleton
Yeah.
sets. Okay.
Mm.
Okay. So up to this is clear, right?
Yeah, yeah.
Okay. So now we have to find the coefficient of k power of n minus one. So that let us try to find out. So so the term involving k power n minus one in this k n minus one
Mm.
arises only by choosing the term k from
Mm.
each factor,
Mm. Mm.
right? When expanding the code.
Mm.
So what we have is so k n minus one.
Mm.
It is nothing but k into k minus one, k minus two up to
Mm.
the last term will be mm, n minus one,
K minus n minus one.
right? Plus one,
Plus one. Mm.
right? So this one is that is fine. So this one is plus 2, right? So here there are n minus 1 terms, right? So here there are n minus 1 terms. So the only way the I can get a power k power n minus 1 is only choosing this k from each of the term, right? So hence the coefficient of so the coefficient of k power n minus 1 is 1, right? And on the other hand, now let us see what happens in kn.
Yeah.
So the contribution to the coefficient of k power n minus 1 in kn. So what will happen in kn? So it arises by choosing the term k from n minus 1 factors and the constant from the remaining term, right? So what will be the contribution? So hence that's the contribution. So this will be minus 1, minus 2, up to minus of n minus 1, right? So this implies the coefficient is minus. So summation I equals to
Summation by
right. I equals to 1 to n minus 1 minus I, right? So this is nothing but minus of n choose 2, right? So this is the coefficient of k power n minus 1 in kn, right?
So this serial is a combination two of n. Oh, I don't get.
Right.
Yeah, 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 yeah. This two. Yeah.
Yes, because it's 1 plus n into n plus 1 by 2, right? That formula you have to use, right?
Yeah, yeah, yeah,
So this you know, right?
yeah, yeah, yeah.
Right. So then the total coefficient is how what? So let us do. So combining this. So the coefficient of k power of n minus 1 in the chromatic polynomial. So the 1 times this minus of n choose 2, that is from k power kn that is coming, and the second is n choose 2 minus the number of edges from the second term. So here
Yeah.
if you simplify, we will get minus the number of edges.
Yeah. Right.
So this is the coefficient of k power of n minus 1. Fine.
Yeah, it's okay.
Right. So next one is, give me 1 minute. So okay. So I think this is fine. Then So next we see what is something called planar graphs. So we'll see that. Okay, so for that, let us see an example.